Welcome. In this lecture, I will present how to set the properties of the engine in QSS, so we later can use it in the powertrain model. This is what a powertrain looks like in QSS. We will focus on the engine, here as seen as the red box in the oval. To find the engine, you start with the QSS library. You should click on the red sub-library with energy converter models. Several different energy converter models then appear, each representing different ways of modeling combustion engines and electric machines. We will use the model denoted CE assignment. CE stands for combustion engine. If we then want to take a closer look to the engine model, look under the mask. To do this in MATLAB Simulink, point at the engine model with your cursor and right-click. Then you will get a menu where you can find mask and you can go on to look under the mask. You will then see the Simulink model of the engine. To the left, you have the inputs to the model, the small green circles, representing shaft speed and torque requested by the vehicle. And to the right, you have the output, the red circle, which is the fuel energy flow the engine needs to produce the required work at this speed. There is also a third input to the engine. This is the velocity change of the engine shafts, which causes a small but not insignificant contribution to the power demanded from the engine. In the center, you can see a big box called Engine Consumption Map. Here you will find the performance map of the engine that was presented in the previous lecture. And if you have forgotten, the performance map is the specific fuel consumption for different operating points, that is, combinations of load and engine speed. Above the engine map, you see a box called Detect Overload and Overspeed. In case your model asks for more load or speed than the engine can deliver, this box will stop the simulation. And remember, there will be no error message telling you what went wrong or where, so you have to find this yourself. Now you know what the engine model looks like, and you have to decide the size of your engine. As pointed out before, size can mean different things. What we will use here is the power needed to run the vehicle as required. If you left-click on the engine model, you will get this dialog box. Here you can see at the bottom two parameters, one in which you can choose engine type, gasoline or diesel, and one area where you should specify the power of the engine. First, regarding engine type, we will use a gasoline engine in these lectures. Then, to find the engine power, you can calculate the power needed to run the vehicle at top speed or the power needed to accelerate to a certain speed, often 0 to 100 kilometers per hour in a certain time. To do the calculations, you can use these equations. The first equation is an approximation of the traction force at top speed, calculated with the vehicle model you have learned. If you assume that the only force that has to be considered is as aerodynamic drag, rolling resistance is neglected, you get equation 1a. And to get the power from there, remember that power is equal to force times velocity, so the power needed for a high speed is as described in equation 1b. The other criterion used to find the power demand of a vehicle is acceleration. An approximation of how much power that is needed to accelerate to a certain speed, v0, in a given time, t0, is given by equation 2. The equations give two values for the needed engine power. Choose the largest value to meet both criteria, both to reach the requested top speed and to meet the acceleration performance requirement. If we go back to the dialog box, we then enter the calculated engine power in the area at the bottom. In this case, we simply assumed it is 110 kilowatt. You now have an engine of a certain type, a gasoline engine, and a certain size given as power. This you will use in your models of a vehicle, but first we have to take a look at the rest of the powertrain.